Hi, welcome back to the class series on Indian Knowledge System, Module 2, Part 2. Myself, Dr. Prasad Pudielam, and you are watching it in my YouTube channel, My Intuition. My Intuition 4865. Please do subscribe if you are not subscribed. Please do support, share the videos. This entire class I am referring this textbook, Indian Knowledge System by Mahadevan, B. Mahadevan, which is the textbook which is given as the prescribed textbook. So only referring to that, I am preparing my study material and taking this class. Okay, and one more textbook is I am referring that is the traditional Indian knowledge that also textbook. Right now here it's not there. Okay, okay, so I'm on to the module 2, numbers and measurements. The next topic is mathematics that I'll cover in the next video. Each term has got many more information is there. I'm just compressing it and giving it a nutshell, trying to compress it, but that is not actual one. You have to give the in detail. You need to go then only it will be useful. Okay, today I'm covering these topics. Number system in India, the historical evidence, the salient features like the concept of zero importance, large numbers and their representation in ancient India, the place values and numerals and the decimal system, how it was there before the present modern system came, how Indian people, the people who lived in this continent, how they used to do that. Then unique approaches to the presentation of numbers by Bhuta Sankhya system as well as Katapaya the system. Measurement for the time, distance and weight, and the Pingala's the binary system actually is done for a poetic one, but it can be connected to the maths like the sequence DA Bujin sequence. The connection also I'm giving in a nutshell in this particular class video. Okay, so moving to the slide 1. Okay, so the foundation of modern science. Okay, the foundation of modern science, it is actually built upon three core principles: the number system, measurements, as well as the calculation. Okay, so these are the not just the academic tools, but they are the essential system which require or which makes the scientific understanding and the technological advancements. So whether it's designing space aircraft or analyzing data, economic data, or even delivering or developing an artificial intelligence algorithm, the ability to count, ability to measure, and the method to calculate accurately is very much required. So these systems, it forms the basic language through which the scientific observations are quantified and they are interpreted. So the laying the groundwork for the experimentation, for the standardization as well as the communication across the disciplines. So the standardizing, the importance of the standard measures were very crucial for the practical tasks such as the construction work or the trade or agriculture, the navigation, or even the civilization. They engaged in the trade or travel, or they need a common understanding of units like the length or the weight and the volume to ensure a fair exchange and coordination between the people. So without such agreement, the trade or the exchange of goods and the service across the borders become very impossible. So uniformity is required in measurement, which also helped in documenting it or transferring the knowledge to the next generation more reliably. So that is a key reason why some ancient civilization they tried while others they actually survived, was others they struggled because they could not communicate with others. The one who the community which could able to communicate properly with the others, they survive. The one who cannot communicate, they will be they'll be destroyed, or they'll struggle a lot. Okay, now what was the Indians' contribution to the mathematics? Third point, that is, uh, the ancient Indians, they actually played a very key role in for the global improvement of the mathematics, and one of the most influential contribution is the development of the Hindu Arabic number systems, which includes the concept of zero, as well as the place value system. So this number system, it is the one we use today. So it has been revolutionized the way calculations were done, replacing the complex numeral system used by other civilization. So the contribution, which enabled more efficient mathematical operations, and slowly or eventually it facilitated in advancement in science, commerce, and technology throughout the world. So the mathematical knowledge which is developed in India was further or later it is transmitted to the Arab world, and then it went to Europe, and now it become a global standard that what we see now. So the significance of Indian mathematics, the contributions, it has been recognized by many scholars across the countries or cultures, and centuries ago itself. For example, the Georges Iffa, who was a French historian of mathematics, he conducted an extensive study on the history of the numbers, and his research, it spans from the 9th to the 19th century, that is 810 CE to 1814 CE, and he concluded firmly that the number system we use today, it is originated from India or Indian subcontinent. Okay, so he traced the evolution, and he spread the spread of the system through various historical records, as well as the manuscripts. Okay, similarly, the Simon, Pere Simon Laplace, was a prominent French mathematician and an astronomer. He appreciated or praised India's the decimal number system. He highlighted how we use the ancient Indians, they used the zero as well as the base 10 place value, which made the arithmetic operations significantly more easy or straightforward, and efficient one compared to the previous method. Al-Biruni, who was a Persian scholar, he traveled during 11th century to the Indian subcontinent, and he studied the Indian science very closely during that time, and he observed that the Indians they used that time uh, very unique, unlike used very distinct symbols for numbers, not like the Greek or Roman culture, where the letters were often used for this. So the symbolization of the numbers was better than that of Greek or Roman during that time. So he also noted that these numerical, the symbols, they are different from regions to region within the India, which reflects the diversity in the local practices, yet all based on a uniform or a unified conceptual understanding of a number system. Though the symbols are different, but people were able, the concept was the same. So together, these acknowledgements of many historians, they shows how the Indian innovators, the mathematicians they were not just only advanced for their time, but also they kept the foundation stone to the global scientific as well as mathematical framework that we completely depend today. Okay. Moving to the next, that is archaeological uh, evidences of early mathematics in India. Not only the words of from or written from by the historian, the mathematical tradition of India. It is even documented in ancient texts, also which is visibly recorded in the archaeological heritage sites. So the urban planning and of the Indus Saraswati civilization, the cities they provided concrete evidences of the early mathematical understanding, which is a key. One of the example is the Kalibangan, one of the prominent cities where the width of streets were not arbitrary but followed a specific measurement. So these widths were laid out in multiples of a standard unit called the Dhanus, which was approximately 1.8 meters in length. So this use of uniform measurements suggested that a developed system and a planning and engineering was there in India. Another remarkable insight into the early mathematics, it comes from the construction of the bricks, which is used in building the houses or the drainage system or the public structures. The bricks consistently followed a ratio of 4 to 2 to 1, 4 to 1 in terms of the length, width as well as height. So this standard ratio was observed across multiple sites in the civilization. Such a consistency, it indicates that not only skilled craftsmanship but also the understanding of a proportional reasoning and the volume which was there, which were the fundamental concept of mathematics. So these were likely established norms which were being followed by there were established norms which are being followed by the builders, which shows that an early form of mathematical standardization was there in architecture in the ancient India. The excavations in the cities like the Harappa, Mohenjo-daro, or Thalavira, or Lothal, it have uncovered a set of scales, measuring scales or the weights. So these weights were they often made of stone, followed by the binary and decimal progression like 1, 2, 4, 8, 16, and so on. So even more impressive thing that the same measurement system were found across the geographically separated cities. So this suggested that the uniform system of weight and measurement or measures that was in use, which would have been very crucial for the trade or for the taxation, construction. Such uniformity, and which again highlights the role of the mathematics in organizing the regulate or mathematic organizing and regulating the ancient society. The importance of the standardized measurement is also emphasized in the ancient literature, Indian literature, that is the Kautilya's Arthashastra, and it is actually written on economics and governance, which is dated around 4th century of BCE, before Common Era, and the Dhanus is defined as a key unit of length. Actually, the Dhanush, it is equal to 96 angulas, where one angula is roughly equivalent to the width of a finger. So another important variation which is mentioned in Garhapatya Dhanush, which was slightly larger, and it is made up of the 108 angulas. So this larger unit was used specifically in for measuring the large areas such as the roads or the distances between two settlements. So the use of such precise and the measurement system shows that the depth of the mathematical knowledge in early Indian as an administrative as well as engineering practices. Okay, next slide. So early legal documentation of place value system. Okay, so the use of place value system, where the position of a digital it determines its value, the value of a digit, and it is the central to the modern arithmetic. So one of the earliest legal document which employed this arithmetic was discovered in Barkucha, known today as Broch in the Gujarat, and it is dated in the year 594 Common Era, and this encryption it reflects a significant mathematical advancement, the ability to express large numbers efficiently using the positional notation. So unlike earlier system which relied on repetitive symbols, this method was scalable, it was concise and remarkably powerful, which laying the groundwork for the decimal system and across the world. So use of zero in ancient India, the Gwalior encryption, a crucial element of the place value system is the concept of zero, not just as a symbol but as a placeholder. So one of the earliest inscriptions showing the use of zero in this context was found at the Gwalior, which is dated to around 876 Common Era. So these inscriptions it recorded the construction of a step well, which included the numeral zero very clearly in its date and figures. So it presents the proof that the 9th century the use of zero had become standardized in written records, which demonstrates a deep mathematical understanding and a mature numeral system in the practice during that time. Now, use of zero, Bakshali manuscript. Even the earlier evidence of zeros, the use of zero, it comes from the Bakshali manuscript, which is an ancient mathematical text which is discovered in what is now it is in Pakistan. The carbon dating places the manuscript between around the 3rd and 4th century of Common Era, which makes it one of the oldest known documents using the symbol, which used the symbol zero. So the manuscript it contains many calculations, which includes even square roots and the arithmetic progression, in which the zero is used both as a number as well as a placeholder. So this indicates not only an understanding of zero role, but also its functional use in solving complex problems even centuries ago before it was adopted in the Western countries. In addition to the Gwalior inscription, another temple in which it that is a temple from 9th century CE. It also found it in Gwalior having the usage of zero. So this record it further confirms that the symbol zero had become widely accepted and integrated into public inscriptions and the even to the administrative records. It use was not experimental or limited to some scholarly text, but it became a practical tool in governance and the public work. That means it was used by common people also. Okay, now the salient features of the Indian numeral system. An overview is given. The Indian numeral system it stands as one of the uh, cornerstone of the modern mathematics, which introduced the vital innovation such as the place value system as well as the zero. as a number and as a placeholder, and the ability to represent very large numbers with very easy and with clarity. Uh, Over time, these features became the basis for the numerical computation, not just in India but across the globe, which influencing the development of science, the commerce as well as the technology. And the root of the Indian numerical system, it can be traced back to the Vedic period, that is around 1500 BCE, and this was a time when much of India's knowledge was preserved through the oral transmissions. Because of this, it was very critical that the numbers had distinct and unambiguous names in Sanskrit. So these names which helped to prevent confusion during memorizing or and recitation, particularly in the religious rituals or the astronomical observations and the early mathematical reasoning. So this structured way of naming the numbers, which laid the groundwork for further development in Indian mathematics. In ancient India, the each digit had a unique Sanskrit name, and these were widely used in the text or in the chants or even before doing the calculations. The nine digits which is mentioned here, that is Ekam, Dvaya, or Traya, or Trini. I studied as Traya, but actually it is Trini. Then Chatvi, Chatur I used to study. Then Pancha, Sat, Sapta, Ashta, and Nava. These are the nine different ways, nine numbers, the unique names which is given in Sanskrit. So these names, it reflects not only the mathematical clarity but also the deep, the linguistic structure of Sanskrit, where precision was valued very much. So the Sanskrit naming conversion, it extended to multiples of tens and even beyond, which further enabled efficient oral computation and the record keeping. So, some of the common multiples of 10 is given here, like Dasha, Vimshati, Trisham, Trinshat, Navati, and Shata. And these structured names helped in expressing the compound numbers and were crucial in developing the arithmetic and the algebra. So this well-defined verbal system, which made the Indian mathematics a highly suitable one for both scholars as well as the practical use during the ancient time. Now, the spread of Indian mathematical concepts to the Western countries, the ability or the brilliance of the ancient Indian mathematics did not remain confined to the Indian subcontinent. Over centuries, these concepts it slowly migrated both east as well as to the west, which influenced the scientific or astronomical or even mathematical development across the Asia or the Islamic world and eventually in the Europe. So what began as innovation in India, which laid the groundwork for the mathematical systems still that we use today. We begin in the east with China as early as around 610 CE during the Swedish dynasty. The historical records it indicate that Indian mathematical and the astronomical astronomical texts which were translated into Chinese. Then this translation work was not just literally; it had deep practical applications. So in 7th century, CE. An Indian scholar named the Gautam Siddhartha. He made a very significant impact in China by developing a calendar system based on the Indian astronomical principles, which is known as the Siddhantas. Additionally, the Indian astronomers they worked at Chinese uh, imperial courts, sharing the methods for the celestial calculations and for the timekeeping. And this collaboration it marked a fusion of the Indian Chinese scientific thoughts. While India was influencing the East, it was simultaneously shaping the Islamic world in the West. One of the earliest known mentioning of the Indian mathematics in West Asia, it comes from the Sebok, which is a Syrian scholar in 662 CE who praised the Indian decimal system and its effectiveness of calculation. So the most important transmission which is occurred under the Caliph al-Mansur of the Baghdad between 753 and 740, 774 CE. The Indian scholars and the text traveled to Baghdad via Sindh, and the Indian numeral system was studied at his court. Here, the famous Persian mathematician Al-Khwarizmi, he he referred as the father of algebra. Actually, it's algebra means he began studying the Indian numerals, and in 1820 Common Era he authored the works which he describes the arithmetic operations using the Indian numerals, referring to the Bijagunida. And these writings were later translated into Latin, with providing Europe with a direct link to the Indian mathematical knowledge. So whatever we study the algebra, it is actually originated from India, and the name was given by the Persian algebra, referring to the Bijaganita, which is directly taken by the Europe and other countries, and now it is called as the algebra. So the story it continues with Leonardo of Pisa. Later we is known as the Fibonacci, who lived between 1170 and 1250 Common Era. The Fibonacci traveled widely, particularly in the North Africa, and he encountered the Indian numeral system via the Arab mathematicians. And in his book, which is called Liber Abbasi, published in 1202 Common Era, the Fibonacci advocated the use of the Hindu-Arabic numeral systems which he had learned from abroad. So this eventually led to the replacement of the Roman numerals across much of Europe, enabling faster, more efficient calculations, and this is revolutionized the trade, science, as well as the finance in the Western countries. Now, the major contributions of the Indian numeral system considered as one of uh, the major significance of or the contributions to the global mathematics or mathematicians. So from the representation of the very large number to the introduction of zero as a mathematical concept, the Indian system has had a very lasting influence. The four key contributions that revolutionized the arithmetic and the mathematical computations are the large numbers, the place value, the concept of zero, and the decimal system. So we'll see one by one in short. One of the most remarkable aspect of the Indian numeral system is its ability to represent a very large number. In ancient Indian text, including those from the Vedic period, which shows that there were specific names for extremely large numbers, which allows the people to represent the quantities far beyond what was possible in other ancient civilization. For example, the concept of the numbers like the laksha or koti, it was already in use. We now only we use the lakh and the crore, laksha and koti. So this system not only made it possible to represent a vast quantities, but also allowed for the computations which involving very large numbers, which were very crucial in astronomy and for even for trade. The place value system, which is become the foundation for the modern arithmetic, and India is credited with developing a system where which the value of a number, it depends upon the position of its digits. For example, in the number 543, the digit 5 represents 500, 4 represents 40, and 3 represents 3. And the place value system, it allows for the efficient computation of large numbers and the development of algebra, as each digit position determines its value. So this concept of positional values, which was a groundbreaking advancement in uh, and it made its arithmetic operations simpler and more scalable, and which laid the groundwork for the way we do calculations today. So perhaps the most important contribution of the Indian numeral system was the treatment of zero as a mathematical value. So before its introduction in India, zero was used as a placeholder in various cultures. But Indian mathematicians, they recognized zero as a number in its own right. So the concept was crucial for simplifying the calculations and to enable more complex mathematics to be happen, such as the algebra and calculus. The zero as both placeholder and as an actual number, which transformed the way people thought about the or they worked with the numbers. So it gave rise to concept of nothingness in mathematics, which led to a very deeper understanding of the mathematical theory. Finally, the decimal system, which also known as the base 10 system, is another major contribution of the Indian numeral system. The Indian system counted in multiples of 10 and formed the basis for the modern decimal system used worldwide today. So this system, it made calculations it made the calculations much easier and more efficient, as every number is a sum of powers of 10. So by using this consistent base, Indian mathematicians, they helped to standardize the arithmetic, which made it easier to learn, easier to teach, and to apply across the different fields. Okay, moving to the next slide. Okay, the concept of zero and its importance. Okay, so again, same concept only explained. Around 500 BC to 300 BC, it was used zero, and around 600 Common Era, it becomes an essential part of Indian decimal system. And the idea of zero, it started from ancient India only, and the Without zero, the complex mathematical problem as well as the calculation of the astronomical data become very impossible, and it is made possible because of zero. And in Sanskrit, it is called as shunya, which means void or empty. And this term captures the essence of zero as the absence of a quantity or called as nothingness. And the word itself, it reflects the philosophical depth behind the zero, that it is not just a mathematical tool but also a concept that represents an emptiness or the lack of presence. Okay, so the development of zero was done by many Indian scholars. First one was in 2nd century BCE by Pingala. Pingala was an ancient Indian scholar who first used the term shunya in the context of the Sanskrit poetic metrics to poetic meters actually to represent an empty or a null position in a rhythmic pattern. Although his use of zero was not as a number, but it laid the groundwork for the symbolic representation of nothingness in mathematics. In coming slides, we can see the work of Pingala, even though he was concentrating on the poetic, but many of them things has been used in the binary system or the modern computation. It was logic based. Okay, so then comes the Brahmagupta around 628 Common Era, who treated zero as a number in his book. The book name is Brahmasputa Siddhanta, and he introduced a symbol for zero and explained its properties, the mathematical properties, such as the rule that when zero is added to any number, the number remains unchanged. Or he also clarified the operations which involving zero, like the subtraction and the division, which were very crucial for advancing the mathematical computation. Then Bhaskara II, in the 12th century CE, he further expanded the concept of zero in his Bijaganita. He explained how adding or subtracting zero from any number which leaves that number unchanged. So Bhaskara, he also emphasized that zero could be treated as a number in arithmetic, and which laid the foundation for more complex operations in mathematics. Okay, the importance of zero. Okay, so finally you can say zero is significance. Its significance cannot be overstated. It has shaped the modern technology, the mathematics and science in the ways that still which impact our world today. Now the large numbers and their representations. One of the earlier texts like the Chandogya Upanishad, which presents the idea of Ananta, or the infinity, and it is not just a numerical concept but a symbol of immortality or a symbol of joy. And the text, it conveys that infinite joy is connected to eternal existence, blending the mathematics with the metaphysical thoughts. The Rig Veda, one of the oldest Vedic text, it contains the reference to very large numbers, which includes the powers of 10. It shows that the ancient Indian thinkers had a mental framework and a linguistic tool to work with the large quantities. In addition to the Rig Veda, you can see the reference in Taittiriya Samhita and the Taittiriya Upanishad, in which the numbers like 10 to the power 13 or even 10 to the power 20, they were used or mentioned. and these were not an arbitrary figures, they and it reflected the cosmic scale, and were and it likely used in many rituals, in calendars, or even the in the astronomical context they have been using. So during the time of Gautam Buddha, a large numbers were part of the philosophy and the doctrinal discourse. So for example, in Buddhist text, like the Lalita Sutra, it is observed that large numbers such as 10 to the power 421, 10 to the power 421, or 10 to the power 140, they were being used to describe very large span of time or the size of the world. So even the epic text like the Ramayana, it is used the large numbers. In the Yuddha Kanda, we can see the size of the Rama's army was described in the Yuddha Kanda of Ramayana, that it is around 10 to the power 28. A poetic but also symbolically immense figure it is represented. Similarly, the Taittiriya Upanishad, it uses 10 to the power 21 in describing the degree of bliss, which again shows how the numerical magnitude was associated with the philosophical depth. So these examples demonstrate that India had a very mature, intuitive understanding of the abstract nature of the large numbers, and extending beyond the simple arithmetic. The representation of numbers in ancient India was both systematic and it was very elegant, particularly in Sanskrit. Example, the Shunya, Ekam, Pancha, Chatvarishtam, Chatvarishat, Chatvarimshat, that is 5 plus 40. Panchachatvarimshat, that is 5 plus 40. Okay, so the Sanskrit, it allowed for the compound number formation, which enabled the speakers and the mathematicians to form large and precise values efficiently and clearly. Now moving to the decimal systems. Okay, actually they lost 3 place values. Let me refer. Place value is found missing. Okay, place values, that is the third one now. Place value, which is one of the most important contribution by the ancient Indian mathematicians, and it also called the positional numbers. Okay, and is based on the idea that the value of a digit, it changes depending on its position in a number. Okay, so for example, the number 345, 345, the digit 3, it stands for the 300 because it's in the hundreds place. So while the same digit in 43, it stands just 3, that is, or even in 30. Okay, so we can see based on the place the number has got its own value, and this innovation was very revolutionized, and it allowed the people to write very large numbers compactly and efficiently. The historical references given, that Agni Purana and the Vayu Purana, it shows the importance, the Sanskrit text, which are describing how the digital place value, it it increases its value by multiples of 10. And one of the most remarkable example is found in the work of Mahaviracharya, who is a Jain mathematician from 850 CE, and he used the numbers to like 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1 to demonstrate the use of place value. So even though the number is very large, like 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1, it is very easy to read and interpret in the Indian system because of the clarity provided by the decimal place value framework. So this example, it highlights the flexibility and the power of Indian numeral system in handling complex and large calculations. If you compare with the Roman system and the system which is developed, originated from India and developed, that system, if you compare, the Romans, they used the Roman numbers, like the which is given in the yeah. So you can see the numbers which they were used like this. For example, the 397 in Roman number, it is mentioned like this, and for 923, 928, they used to refer like this. Okay, so that was little bit complicated one, the Roman system, compared to the number system which is developed by the Indian origin. So the place value system, it is invented in ancient India, and it remained the foundation for all modern arithmetic and the computing, and which enabled not just easier calculation but also the representation of exponentially large numbers, a truly transformative idea in the history of mathematics. Now we'll move on to the uh, decimal systems. Decimal system, it is based it is a base 10, meaning it uses the 10 symbols 0 to 9 to represent all numbers. So the evidence for the ancient use of decimal system comes from multiple sources in Indian mathematics. The Bhaskaracharya, also known as the Bhaskara II, in the 12th century Common Era, clearly stated that the system was already used by his ancestors. And this confirms that the decimal system had been in widespread use long before his period, Bhaskaracharya's period. In his Bhaskaracharya's famous mathematical text Leelavati, the Bhaskara 1, the earlier mathematician, actually confused with the Bhaskara 2, he described the numbers as large as 10 to the power 17, assigning each place a distinctive Sanskrit name, which showcase both the depth as well as the sophistication of the Indian number theory. For example, the decimal names on Leelavati, the text written by the Bhaskaracharya, you can see the examples like Eka, Dasha, Shata, Sahasra, Ayuta, Mahapatma. Mahapatma is 10 to the power 12, which is equivalent to trillion. and parartha, that is 10 to the power 17. And this system of naming not only reflects the mathematical uh, ingenuity, but also it highlights how deeply the mathematics was integrated into the language and the culture. Now we move on to the third topic, unique approaches to represent the numbers. Okay, we'll see in detail about the Bhuta Sankhya system or Bhuta Sankhya Paddhati and Katapaya, the system or Katapaya, the Paddhati. Okay, we'll move on to the next slide. Bhuta Sankhya system. Bhuta Sankhya, the word Bhuta, it means an object or an entity, and Sankhya, it means a number. So together if you consider, it's a being, the numbers are being based on some or the objects instead of directly writing the digit 1 or 2. So this system, it used words that symbolically represents those numbers. For instance, if we mention I, it stands 2, so 2 eyes we have, since we have 2 eyes. And moon, it is 1. And the Veda, we already seen that there are 4 Vedas: Rig Veda, Yajurveda, Samaveda, Atharva Veda. And the gunas, say that we have 3 in gunas: Sattva Guna, Rajas Guna, and Tamasa Guna. Okay, so these were the way the Bhuta Sankhya was used. So the features of the Bhuta Sankhya system, it uses the objects or ideas or even deities from the uh, daily life or the religious or philosophical tradition to represent the numbers. The digits from 0 to 9, it could be expressed using a variety of terms which is chosen on logical or symbolic association. For instance, the number 1, it is represented by the moon, and it not having only one word. The moon, it has many different words can be used, like Chandra, Soma, Indu, Shashina, Vidhu. And these synonyms, they also gave this system a great flexibility, mainly in the Sanskrit poetry and in the astronomical verses. So a poet could choose the most rhythmic or the most aesthetically suitable word, but still conveying the correct number. So another important feature is the system, it could represent fractions also. For example, the Kala stands for 1 to the power 16, or Kushta, that is 1 to the power 8, Shafha, that is 1 to the power 4. So this capability made the Bhuta Sankhya system or Bhuta Sankhya Paddhati a powerful, not just for artistic expression but also for the scientific and mathematical writing. The categories of word which were used. The first category, it includes the direct numbers or number names like Shunya, Eka, Dvi. Shunya means 0, Eka 1, Dvi 2. The second category, it consists of natural elements or the physical objects like the earth, sky, moon, fire, star. For example, the moon, it might represent 1. Fire could represent transformation or one of the 5 elements. The third category, it is from the animal kingdom, like elephant, horse, snake. Depends upon the cultural association with the, for example, a snake could represent 1 due to its singular form. Now the fourth category is based on the human body parts. Common example includes the eye, which represents two, and or arms or legs, or similar logic is being used. So the fifth category, it involves the deities from the Hindu culture, or such as Shiva, Vishnu, Indra, Agni, and each deity could be associated with a number based on the myths or the attributes, or the symbolism. And finally, we have the conceptual or the philosophical terms such as the units of time, like days or months or season, and the Panchabhuta, the five elements: the earth, water, fire, air, and space. And these categories gave the system both richness and as well as the flexibility. Now, how were the numbers written using the Bhuta Sankhya system? Okay, let us take some of the examples straight away. An example is given, which is given in Sanskrit, Hindi. Chandra Yuga Pandava Ritu. Chandra means moon. Moon only one is there, so number one is introduced there. Okay, so this one. Yuga means there are four yugas. Then Pandava we know Pancha Pandavas, five Pandavas, so number 5. Ritu, we have 6 seasons. Ritu means season. So the number digits are 1, 4, 5, 6. If you reverse it, it becomes 6541. Therefore, Chandra Yuga Pandava Ritu, a poetic representation is 6541. For example, another example, that is Dvi Indriya Naga Graha. Dvi Indriya Naga Graha. Dvi means 2. Indriya means senses. 2 senses. Naga means there are 8 Nagas. Therefore, the number 8 comes. And Graha, that is planets. 9 planets. Okay, so 2, 5, 8, 9. If you reverse it, becomes 9582. So this is 9582. Third example, that is Shunya Chandra Grihavarsha. Grinavarsha. Shunya means 0, Chandra 1. Grina means the gunas. Gunavarsha, not Grina. Gunavarsha. So Guna 3 gunas are there. And Varsha means year, only 1 year is there. So the digit comes to 0131. If you reverse it, you can write as 1310. One more given, Vasubhana Darshana Shashina. 8 Vasus are there. So Vasu means represents 8. Bana, that is the arrows of Kama. There are 5 arrows of Kama. Therefore, number 5 represents Darshanas, 6 Darshanas or philosophies. So the number 6 comes on for Darshana. Shashina, that is moon. Moon means 1. Therefore, the numbers 8, 5, 6, 1. If you reverse, it becomes 1658. Okay, you can see the bigger one, even bigger ones are possible. Example given is Nandadinaga and Adgabana Shata Kruta Indava. Okay, so it represents 92765 641, and if you reverse it, it becomes 14 crore 65 lakh 67,298. So as we can see, using this particular system of Bhuta Sankhya system, it was not just symbolic but also a practical and a compact, especially when writing large numbers in poetic or quoted form. So you can remember a particular poem. The poem tells what are the numbers which is used to represent that particular system. Okay, for example, some of the common words which are used, which is in the text mentioned here: shunya, ananta, purna, kha. These are representing 0. Then eka, chandra, prithvi, adi represents 1. Dvi or ashwin, dvandva or ayana represents 2. Guna, rama, agni, trinetra, this represents 3. Veda, yuga, varna and samudra, it represents 4. Bana, pandava, indriya, these represents 5. Anga, ratu, darshana represents 6. Adri, swara, chandas, dhatu represents 7 based on the number. So I'm not reading the complete one. We'll go to the applications. What was the important application is given as the approximation of pi given by the Madhavacharya. He used to encode the how to calculate what is pi, the value of pi 3.14. That simply now we say it was calculated that time itself, and how it can be calculated, how we can come to that particular value, that is given as a encoded form, like the shloka vibhuta netra gajahi hutashana triguna veda bha varana bahu. And if you see the digital sequence as per the Bhuta Sankhya system, the totally you can say that will reach to a number called 28274333888233. Okay, so a number we got. Now what is to do with that number? Then the decode was also given to what to do with that number and how to get the final result of pi. Okay, so the decode is like this: navani kharva mitte vritti vistare paridhimanam midam jagadur bahuda. Means the wise, the meaning is also given that the wise declares the circumference of a circle of diameter 9 nikharvas. Okay, so that means those who are not wise, they fail to understand that this word is circumscribed by the vast extent of the sphere as measured by the circle of a new measure. So 1 nikharva means that is the 10 to the power 11. 9 nikharvas means 9 into 10 to the power 11. So he encoded the value of the circumference of pi by dividing the number, the large number which is took from the earlier sloka or the usage encoded form, divided by 9 into 10 to the power 11, and approximately the value is given. So this is astonishingly accurate approximation of pi, even up to the 14th decimal place. So this is the example which shows how symbolic logic language and the mathematics were deeply integrated in the ancient Indian science, making it not only a precise but also poetic elegant. Now we are struggling to read it, pronounce it. That time they were calculating the value of pi. Now we know that pi is this value. We need only to by heart it. We don't want to calculate how it is getting calculated. So that is the present education system that we were, our grandparents, their grandparents, they suffered. Before that it was so interesting. system. Now we are struggling to get it back step by step. Not possible at one generation, not possible. At least next generation people should know how these systems work, so that they can find better applications than the present modern mathematics or the modern whatever science. Something even better innovations are possible if we could able to understand the olden Indian, the traditional Indian education system, and the way it was used. It is possible. Now we'll move on to the Kattapayadi system. Kattapayadi system is also a very brilliant memory-based numerical encoding system, which is used by the ancient Indians, and it called as a Kattapayadi Paddhati. Like Buddha Sankhya Paddhati only, in which they express the number through words, but instead of assigning a symbolic value to an object, it is assigned digit to Sanskrit consonants. So this method helps to memorize long numbers by turning them into a pronounceable, often a poetic type expressions. How does it work? So the basic idea is that each consonant in Sanskrit alphabet is assigned a numerical value from 1 to 9. Like the vowels like a, e, and so on, they do not carry any numeric value, so they are just used to make the resulting word which is a pronounceable one. So when reading a word, we extract only the consonant immediately before each vowel to decode the number. If multiple consonants may be assigned for the same digit, which provides a flexibility in forming the word. So the Kattapayadi system is called because the first few digit assigning consonants are, they are ka, ta, pa, ya, ka, ta, pa, ya, like that. Okay, you can see that here. Okay, so I given the table used for the Kattapayadi system. So this table, you can see ka, kha, ga, kha, na, cha, cha, ja, cha, nya, ta, tha, da, tha, na, ta, tha, da, tha, na, pa, pha, ba, pha, ma, ya, ra, la, va, sha, sha, sa, ha. They are arranged to 1 to 0. Okay, so the mapping is done here from 1 to 9, and even the 0 is also given, and even some of the words which are not there, if they used, it has to be given the value 0. So based on this, we can they can give different words, interesting words to represent a number. Okay, a simple example given here, that is bhavati. Bhavati is a common usage in Indian culture or Sanskrit. Bhavati means a respectful lady, that what we use as such. But bhavati, it is can be used to represent a number, where bha is for a number 4. Where is the bha? Here comes the bha. Bha. Then va again 4. So 4. Now we need t. T is actually, it is there in the sixth column, you can see. Okay, so bhavati, it represents 446. When we reverse it and write, it becomes 644. So 644 can be represented as bhavati. If you want to do some calculations, you can use bhavati, adhikam, like that. Some words, sentences can be used, and it can be calculated. Another example given is sarvartha silastira. Sarvartha silastira. Sarva Saravatha chi la sthiraha. Number is mentioned, and if you reverse it, it becomes this particular bigger value. Another one is given, that is ayur arogya saukhyam. Ayurarogya Saukyam is a very common usage that is for the entire life. You should have good things. Saukyam means no well wishes. Okay, so it can be decoded as the number 17122110, a bigger number. So the benefits are mentioned. The first is the systematic and regular nature, unlike the more symbolic by the Bhuta Sankhya system. There is no ambiguity. Every consonant has a definite digit, and it is a rule based. So no need to worry. Check the rule, check the table, and give the number. So and do the calculation. So second, it was ideal for the oral transmission. The teachers and the students could easily remember and recite a huge numerical value which is embedded in this sloka or these long songs or even mantras. Okay, no need of a written document not needed. It can be transmitted through orally. That was what happened in ancient India. And third, it is enabled a meaningful composition. Instead of remembering a string of digits, you remember a very beautiful phrase. And most importantly, it was extensively used in Jyotisha, in the Panchangas, or even coding the mathematical constants like pi, astronomical values, the planetary positions, etc. So this system is a living example of how the Indian knowledge, the traditions, with a precision was there, aestheticity was there, beauty was there. Okay. The importance of Katapayadi system mentioned in detail that it is used in astronomy, that is Jyotisha, to encode the planetary constants. It is used in Panchangas, that is the Hindu calendar that we use to denote this, and the tithis as well as the nakshatras we calculate using the Panchanga, and the education for the poetic composition and number recitation, it is very important. Even the music, the logic text, they use this method, Katapayati method, to encode the numerical rules. So today this system is being revisited under the umbrella of the Indian knowledge system in academia, which offers a deep insight into our civilizational approach to data representation and the memorization. Okay, so now moving to the measurements for time, distance, and weight. Okay, general significance: construction, engineering, the astronomy or medicine, governance and economy. Everywhere we need the use of the time or distance or weight. And in ancient India, they were very regular to this, as we can see seen from the evidences as well as the text given by the other historian mathematicians. In the famous mathematical book called Leelavati by the Bhaskaracharya, it includes the detailed computations for the areas, for the volumes and the length. So the Ashtashastra of the Kautilya, where he written an early about the weight and measures which is used in the economic policy, the market regulation, and even in taxation. The Ayurveda Samhita, which includes the mainly the Charaka Samhita and the Sushruta Samhita, it uses the standardized units of time, weight, and volume for the medical procedures and prescriptions. So this is deep integration of measurements in multiple domains shows that the Indian scholars, they developed a remarkably advanced system for quantification centuries before the modern system were formalized. Now, some of the fundamental units and the Paramanu. In Sanskrit, Paramanu means the smallest unit or indivisible particle, called as atom. Now, it was mentioned that time itself as Paramanu, which is indivisible. Though not based on physical or atomic structure like the modern science, the idea of Paramanu, it reflects the profound understanding of the minute scales. The ancient Indian text in which the Paramanu was defined as the smallest unit of length, which is equivalent to approximately 2.88 into 10 to the power minus 7 millimeters, and the smallest unit of weight, it is 5.79 into 10 to the power minus 5 grams, and the smallest unit of time is around 1.31 into 10 to the power minus 5 seconds. So the astonishing precise value showed by the Indians that they were not only observing and experimenting with the larger scale as planet or the architecture, but also they are calculating the microscopic level well ahead of their time. The notion of such fine divisions or the suggestions that the measurement system were based on logical scaling, and which enabled the calculations from the atomic level to the cosmic level. The Paramanu was not just a spiritual or a philosophical idea; it was the mathematically integrated into the system which is used in daily life, and specialized science like Jyotisha, that is astronomy, and the medicine Ayurveda. Okay, move on to the values. Okay, it is given here that the values, the paramanu, it's the smallest unit of length, or philosophical and calculatable minimum, which is used in text, and the measurements were very fine distinctions were necessary. While not directly measurable like modern millimeters, but it reflected the understanding of the scale, minute scale. Then angula, meaning the finger width, one finger width. That was a standard and a very practical unit based on the human anatomy. One angula was roughly equivalent to 16.764 millimeters, which become the building block for the larger measurements. Then dhanusha means bow, and in the context of measurement, a dhanusha was typically 108 angulas, which is equal to about 1.8 meters, nearly the height of a person. So this was the useful unit for the architecture and the battlefield formations. Then yojana, it was a large unit of length used to measure the geographical distances. One yojana is generally considered to about 14.48 kilometers, and ancient texts like the Ramayana and the Mahabharata is frequently mentioning the distances in yojana when describing the journey over the battles. Shatayojana, Shata one of the famous song that I remember. Okay, now the evidences of precision and usage. If you take the Indus Valley civilization, for example, at the sites like the Lothal or Mohenjo-daro, the archaeologists, they have found the graduated scale markings on the artifacts to show a precise unit of around 33.528 millimeters, called as Indus inch. The scholars, they called it as the Indus inch. It shows the standard linear measurement which were around 5000 years ago. We can also find the references in South Indian temples like the Tirupukuri, where the stone inscriptions defines specific unit of length likely to help the monsoon and the architects to maintain uniform proportions while building the temples. So this acted as a kind of reference the scale engraved in stone, which is a brilliant way to ensure that standardization even if tools were lost or if the tools were worn out. So what we see in the codified system of distance measurement, it everything from spiritual rituals to the urban planning, they pick travel accounts. So most importantly, it was widely understood and applied, which ensures the uniformity and continuity across vast regions and historical periods in India. Measurement of time, that is Kalmapana. The time concept was very cyclical and it was very precisely structured. The time measured from microscopic to the cosmic duration. Some of the examples are given here, like Truti, Veda, Ritu, Ayana, Manava Varsha, that is human year, Divya Varsha, Mahayuga, Kalpa. Kalpa means 1000 Mahayugas. That is around 4.32 into 10 to the power 17 human years. So this is impressive. Not just the numbers but the philosophical meaning which is attached to these scales. A very dynamic universe constantly in motion, which is governed by timeless cosmic cycles. The applications of these time measurements are there for the Jyotisha, the astronomy and astrology, the science of astronomy and astrology, the movement of the celestial bodies, which is tracked with incredible details and it is used to determine the uh, time for rituals or festivals and the farming cycles. Then the Purana in the text like the Vishnu Purana or Bhagavad Purana, these time units they were used to explain the creation or preservation or the, the dissolution of universe. So such a system it reveals an integrated understanding of the physical or the metaphysical and the spiritual dimensions of time. Measure of weight, that's Bharamapana. They used in Ayurveda we need exact weights of the herbs and the basmas, which is the calcinated metals. A famous text like Sharankada Samhita, it gives a precise gram like unit of formations. Okay, so in our Arthashastra or the Sarankada Samhita, everywhere it is clearly mentioned how ancient Indians how they used the units of weight. It was not only about more than just the technical accuracy, it was a matter of the ethical conduct which measuring correctly as seen from as a form of the dharma, which is a honest way of life, as mentioned in the uh, Sangatha Samhita, Saranga Samhita. Okay, I'm not getting any much from that. The integration across other fields, all the time, the distance and weight. It is in Ayurveda it is required, Jyotisha it is used, in cosmology it is used, in Vyakaran, Vyapar, that is business, commerce, it is used, in architecture, science of architecture and engineering it is used. So, so when we talk about the ancient Indian knowledge system, it is not about just say that it was so great, the nostalgia. It's about recognizing a technologically rich, ethically aware, and a scientifically grounded civilization was there as our ancestors, very long before the modern metric system which came into existence. The last topic, that is Pingala's work and the binary system. Pingala was a great scholar. He wrote the book Chanda Shastra, which is the science of meters, in which he used the syllabus or syllables and the binary representation. The basic poetic unit which is used by Pingala is the akshar, or which is called the syllable. One akshara is one syllable, and each akshara in Sanskrit verse was classified into two types based on the length of pronunciation. Lakhu, a short syllable, a short shabda, and Guru, a little bit long shabda or syllable. And it can be represented as a binary code. The shorter one can be represented by 1, and the longer one as a 0. This is just like a binary notation of a representation. And Pingala, he used this shabdas to construct the metric patterns using the mathematical logic. Essentially performing a combinatorial through poetic rules. So the Pingala and the Chanda Shastra, their work, it stands one of the earliest known example of the binary logic hidden within the verse, but still anticipating a very foundation for the modern computing. The syllables, the shabda used, akshara used, and guru is a long form, lakhu is a short form, and with that arrangement they will get a particular meter called as chandas, and you can see the rhythmic, the binary system in detail. There are certain rules that Pingala mentioned to give the meter for the required length. Meter is used in measurement of length. Same way, the measurement of the length of a sentence in a poem, that is called the meter, or the chandas. Chandas, we can in Sanskrit they use chandas. Okay, the long vowels like a, e, u, uh, long vowels. It is a guru syllabus, syllable, guru akshara. For example, Rama, Ra. It's not R, it is Ra. So it is a guru. Ma, it's again no, it's Rama. So Ma is a short. So it's a lakhu. Another example, Gita, Gi. it is a vowel gi long, so it is guru. The akshara is guru. Ta, ta is not gi ta, it is gita. So ta again it is a guru. So both are guru in the two akshara used are guru. Second rule that the even if the syllable contains a short vowel, it becomes guru if it is followed by a consonant cluster, which is two or more consonants with no vowel in between. For example, Krishna, where Krish can be represented KRS Krish, Krish is a short vowel plus a consonant cluster sna, sna. So it becomes a guru. And the na is a short vowel, Krishna. So it becomes a lekhu. Or in sprishta, sprish, that is a short I, ish, and the cluster ist become guru, and ta is lekhu. Little bit complex, but it can be practiced. Rule 3, that is anuswara, that is the nasal dot. Whatever comes from the sound comes from so it is represented in Sanskrit letters with a dot on the above the letter. For example, hum, the final hum is guru. Same with the swayam, the end is guru. So now rule 4, which ends with visarga, aha, that sound, if ends like namaha, mah, ends with visarga, therefore it becomes guru. And agni, that is again visarga, it becomes, the akshara becomes guru. Now rule number 5, that is an optional rule. If a syllable is the last in the metric line, it can be treated as a guru. If the akshara is in the last in the metric line, it can be treated as guru, even if it is does not meet any of the previous rule. This is called pathandya guru. Padandya guru, not pathandya guru. Padandya guru. Better one. Okay. For example, in kritam, even though the tam doesn't have any long vowel or cluster, but still it's if it comes as the pada andya akshara, then it becomes a guru. It can be treated as guru. In tushta, ends with visarga, therefore it is obviously it is a guru. Okay, now how Pingala used binary representation. This is about 2000 years ago. In the Chanda Shastra, he wrote the guru and lekhu usage. For the poetic words to become a string of words, a binary string of words, which can be represented as our computer binaries using 0 and 1. Let us take an example of the word part given in Bhagavad Gita, the yada yada hi dharmasya glanir bhavati bharata. It is made up of 16 akshara syllables using the akshara rule. We can convert it into 16-bit binary string. So it is similar to the digital encoding that we do today. So to simplify and to organize these aksharas, or syllables. Pingala, he grouped them into a set of three called ganas, and each gana is a triplet of Lakhu and Guru, giving us 8 unique binary combinations, just like the 3-bit binary numbers. So it is given in this table form, and we use this to remember Yamata Raja Bhanasa. That is the usage where we can predict, or with that we can see what is the pattern given there. These are the 8 ganas which is defined by Pingala, and each corresponds to a binary pattern, which helps the poet to remember them. And he created a mnemonic string using the sound that Yamata Raja Bhanasa. This phrase Yamata Raja Bhanasa, it contains all the 8 binary triplets in a particular sequence, and it is used to memorize or memory aid for the poet to recognize the rhythmic pattern, which more interestingly now becomes the sequence representation in mathematics. In modern combinatorics, we have the de Bruijn sequence, which is a cyclic string which contains all the possible combination of n-bit numbers, n-bit binary numbers, n-bit binary numbers without repetition. And Pingala mnemonics achieved exactly this for 3-bit groups. So he didn't formalize it. Eventually, he grasped it for 2000 years ago. So if you compare the timeline, the binary logic was introduced in Europe by Leibniz in 17th century, but Pingala system shows that the binary idea applied to the rhythm and the meter already emerged in ancient Indian centuries well before. So to conclude, the Pingala's contribution is just to Sanskrit poetic, but to the evolution of binary logic, algorithms, and the pattern recognition. So his work, it beautifies, or it beautifully connects or bridges the literature and the mathematics, something that modern education is only now beginning to reappreciate. And Pingala's work, and we are discussing an ancient poetic text in the age of artificial intelligence and this digital technology. Why we are discussing, the answer is how far ahead the Pingala he actually was. What he developed was not just a method to scan viruses. It was an early form of the binary representation, the one that predates modern computer logic by over 2000 years. And this shows a deep intuitive understanding of the binary arithmetic, combinatorics, and even a cyclic structure of logic, all presented in the form of poetry. And in today's world, these ideas form the very backbone of the computer science. Binary code, the zeros and one used in every computer system, is the same principle Pingala used with the Guru and Lakho. So his cyclic mnemonic sequences, what we now call the de Bruijn sequences, it is used in coding theory and data compression, where the goal is to efficiently represent or transmit the data. Even in artificial intelligence, we use patterns, whether in sounds or language or visual data, to train the machines. The same rhythm-based encoding system was used by the Pingala, and now it is repurposed to teach artificial intelligence how to generate music and poetry. So Pingala system is not just a artifact of the linguistic beauty. It is a living concept that bridges ancient thought and modern computation. It is a poetic precursor to the data science. So that's about the numbers and measurements. Hope it was little bit lengthy, but I covered whatever given in the textbook by keeping the textbook in front of me only, referring it. Some of the pronunciation I was not able to do properly, not able to remember some of the. It requires a lot of training to learn as well as to teach this, but it is very much important and very much needed for the present generation and the next generation, so that since we are in the world of artificial intelligence, machine learning, data science, the system that used by the ancient Indians, the experts, if Meta if continued it, the present artificial intelligence might have introduced very long back. Since we lost those ancient education system by the introduction of this present system that what we are going on, the British system introduced in 1800, still continuing, making us to learn only very little what is only required for doing a particular job, making us as clerks who knows only one work, not the next work. Engineer knows only engineering, doctors know only that. There are so different categories. Ayurveda different, hand different, leg different, eye different. Such type of a system, education system we are in, and it won't teach us logic, it won't teach us the ethics, it won't teach us human values. Everything was now slowly getting introduced by the All India AICTE, or the central government, slowly introducing all the concepts which I am trying to learn, so that at least I can practice it every year, so that I can improvise it further and I can give a better presentable videos to my students of my intuition 4865. Please do subscribe and support. Thank you.